Welcome, everybody. We are starting the ASHRAE South Brazil and the IBIPSA Brazil Building Performance Simulation Conference. This will be a series of 4 webinars with speakers of Robert Lamberts, Ross Montgomery, Dury Crowley, across these 2 days, this Thursday and Friday. I would like to welcome now Bruno Martinez, ASHRAE South Brazil Chapter President.
Thank you, Felipe. Hi, everyone. Most of you are asking why we are speaking English. This conference was open for all international members from IBIPSA Brazil and ASHRAE Brazil. So this is why we decided to make it in English. First, I would like to welcome you for the first ASHRAE South Brazil chapter and IBIPSA Brazil Building Performance Simulation Conference. I would like to thank IBIPSA Brazil, our partner organizing this conference. IBIPSA and ASHRAE has a great synergy as associations. I hope that our partnership lasts for a long time and we can work together in upcoming events. Thanks for our speakers. Thank you for sharing your knowledge with us. It's a pleasure to have you here. Special thanks for our sponsors. Without your support, the conference would not have been possible. Thank you very much. Also would like to thank Chapter Brazil. Chapter Brazil and South Brazil are partners. They are together doing everything. This event is from Chapter Brazil as well. Thank you very much. And also, I would like to say special thanks for the group that organized this conference, especially for our CTTC, Felipe Accorsi, that already speak with you. He made a tremendous job putting these things together to make this event happen. Thank you very much, Felipe. And thank all the staff, Ana, Gabriel, Patricia, Professor Lamberts, everybody that made a really impressive job. A lot of you don't know, but thank you. A lot of you don't know, but this conference was designed to be an in-person conference in a beautiful island in the south of Brazil called Florianópolis. Unfortunately, due to the coronavirus, we had to redesign the event and make it online. It has a really good side effect. Now we can reach more people, and it's a great opportunity to share our knowledge with our international members. We are proud to say that we had more than 400 registered attendees. Thank you, guys. I'm sure you're going to enjoy our conference. We have the best speakers in the field, and there's a lot of great knowledge in building performance simulation. I'd like to tell a little bit about ASHRAE in the South Brazil chapter. ASHRAE is American Society of Heating, Refrigeration, Air Conditioning Engineers. ASHRAE is celebrating its 125th anniversary. This was founded in 1894 and is a global society with more than 57,000 members from over 132 nations. It's a huge professionals association. The South Brazil chapter is a brand new. It was founded last year, and Brazil is the first country in South America to host 2 chapters, the Brazil chapter and the South Brazil chapter. It's a great achievement for ASHRAE in Brazil and South America, and we are growing very fast around here. As we are in our first years as a chapter, we need a lot of volunteers to participate in the growth of our chapter. So if you are an ASHRAE member living in the south of Brazil and want to increase your engagement, please let us know. Felipe will provide our contact information during the conference. Feel free to contact us. Now, I would like to introduce my friend and one of the speakers, Professor Roberto Lamberts. Roberto Lamberts graduated as civil engineer from University Federal do Rio Grande do Sul. He also has a master degrees from the same university, Universidade Federal of Rio Grande do Sul, and he is a he has a PhD of civil engineer from the University of Leeds, England. Roberto Lambert is a professor of civil engineer at the Federal University of Santa Catarina, and he is the director of the Laboratory of Energy Efficiency in Buildings. He developed the research in areas like thermal comfort, energy efficient buildings, building simulation, and bioclimatology. He's a CNPq researcher level 1A. He is also a counselor for the Brazilian Council for Sustainable Buildings. He's vice president of Ibiza Brazil. He's member of the CGIEE and the building and he's part of the building working group of the Ministry of Mines and Energy. Also, Lambert is the Ibiza Brazil Fellow and the Ibiza Brazil founding member. Lambert has more than 100 articles and 15 books. Welcome, Professor Lambert. Thank you for the partnership to make this conference happen. I wish you all a great conference. Thank you very much.
Thank you, Bruno. Can you see my screen now? Hi. Thank you, Bruno, for this nice introduction. It's a big pleasure for me to be here with you, trying to entertain you during this confinement times. I will start speaking a bit about IBEPSA. It's not a very well-known association, not like us ASHRAE, but they do internationally a lot of cooperation, and we hope to keep in the same tracks here in Brazil. So IBEPSA is the International Building Performance Simulation Association, and we have the Brazilian chapter. Who we are? It's a non-profit international society of building performance simulation researchers, developers, and practitioners dedicating to improve the simulation of the built environment. We are approximately 4,000 members worldwide, coming to 32 countries. This is to give you an idea of the countries that we are involved in, and it's always growing. So Brazil is one of the members. We do building simulation conferences apart from local conferences, but the building simulation conferences are the international conferences. The last one was in Rome last year, and next year we hope to be in Bruges in Belgium. So if you are doing research on this area, please submit an abstract to the conference and try to be there. Bruges is a very nice city to have a conference. I have to mention that in 2001 we did building simulation here in Brazil, as you can see here. It was a nice conference, but it's small. At this time we started IBEPSA Brazil, and it was just before an international crisis. It was just before the World Trade Center accident. We were very lucky to be able to do the conference because in a month after the conference, everything was closed. So try to be in Bruges next year, that I'm sure you will enjoy it. So what IBEPSA does, we have regional affiliate conferences, workshops, and activities. We have IBEPSA education webinars. You can see in our website some of the webinars that we have organized already here in Brazil. And in the international website, you can see proceedings and a lot of things to entertain you on building simulation. IBEPSA communications, we have IBEPSA news twice a year. It's very important to be read by people involved in simulation to be updated in what's happening on the world. IBEPSA student modeling competition, also every 2 years. We have IBEPSA projects and IBEPSA publications. We have the Journal of Building Performance Simulation that was started by IBEPSA and has grown fast, and it's a very important scientific journal on this field. And we have also IBEPSA endorsed books. So starting on the left, you will see the webinars. So this was one of the sessions that we organized in the past in the international agenda. You will see a lot on the international side to entertain you. IBEPSA News, you can stay updated with the simulation community. Journal of Building Performance Simulation can keep you updated on the scientific evolution. This is the IBEPSA book. Jan Hansen and myself edited this book. It's a very well-known book on building simulation, and this is the second edition that was quite enlarged. And these webinars here are based on the chapters of the book. And we have IBEPSA projects, Project One, that is very important, related to the evolution of BIM and building performance simulation. So if we think in IBEPSA Brazil evolution, we started in 2002, just after the building simulation in Rio. We are 18 years old now, and it's a solid association with a lot of members and trying to do a lot of things together with ASHRAE. That is also a very solid association. The board that we have now for 2020 to 22 is Ana Paula Mello is the president. I'm vice president. We have Anderson Letti as a secretary, Martin Ordenis as a treasurer, Alberto Hernandes as a board member, Bruno also a board member, doing this connection with ASHRAE, Leticia, and David Weck also on our board. So we are about 200 members. Currently, we charge no membership fees and rely on profit from organized events. So if you want to join IBEPSA Brazil, write us an email. It's IBEPSA Brazil Google Groups, the discussion group that is handled by IBEPSA. Our website is this one, so you can go there and see what we have to offer you, and if you wish, join us. So IBEPSA Brazil challenge and wish list, we want to be technical and scientific support to the Brazilian energy efficient building labeling program and standards. Energy simulation course is something that we see that the audience is very much wanting to have. Interface for Energy Plus for web simulations is something that we've been involved in the past, and we plan to work on this again in the future as we have funding. Treatment of climatic data for Brazilian sites. We did this in the past, and we are also always involved on this. Develop dynamic benchmark models for energy consumption. Energy audits, site visits, questionnaires, symposiums, and IBEPSA Brazil best papers, meaning that we try to choose the best paper written by a Brazilian member from IBEPSA Brazil to be sent to the World Conference. So this is the introduction to IBEPSA Brazil. Thank you for that. And now, very quickly, I jump for my presentation. So now I change my hat to, oh, sorry about that. I just did something wrong here. So this is the presentation that I prepared for you today. We're going to speak about building energy labeling scheme, but I'm also going to speak a bit about our very briefly on climate change, global status report on building and construction, give you an idea of the area of building construction worldwide, the future of cooling, the energy consumption in Brazil to give you an idea of the importance of buildings, energy efficiency in buildings, building energy labeling, the residential label, non-residential label, the performance gap as we see it today, and some conclusions. After that, we'll have questions. Please send your questions via the system, and don't be afraid of sending them in Portuguese. I'm sorry to speak to you Brazilians in English, but this was a prerequisite for having this more international event. So when we look into the climate, how it's changing, we can see that the 10 warmest years occurred since 2005, with the last 5 years comprising the 5 hottest ones, as you can see here in this graph. So the 5 years with highest temperatures have been happening since 2015. And most of the 10 are on the last 15 years. So it means that the weather is really changing rapidly. If we want to have a look on the global status report on buildings and construction, this is a very interesting document. What we can see is that building constructions accounted for 36% of final energy used and 39% of energy and process-related CO2 emissions in 2018. So 11% resulted from manufacturing the building. So we have energy embodied in the materials, steel, cement, and glass. Global building sector emissions increased 2% from 2017 to 18 to reach a record high, while final energy demand rose 1% from 17 to 18 and 7% from 2010. And we have to keep in mind that the building stock is growing fast and mainly on developing countries. So, and it's meant to be doubled by 2050. If we look into the changes that we'll see in the future, or we've been seeing from 2010 to 2018, we see a very large growth in floor area, population not as high, energy demands, and emission. So, and we'll see this growth increasing in the next years. When we look into the final energy intensity change, we can see that end users as space heating tend to drop. Lighting is tending to drop due to efficiency of LED, for example. Water heating is dropping, but space cooling is going to grow. So as we are speaking to people involved in ASHRAE, this is a very important end use that is going to grow fast in the next years. When we look into the building energy codes around the world, we can see not many blue areas, and the blue will be mandatory for the entire sector. So we want to make the world more blue in this sense. And here, regarding energy certification programs also, it will be nice to see more mandatory certification programs widespread. So when we read this global roadmap recommendations, we understand that we have to be very careful with urban planning, with new buildings. New buildings have a high potential to be more efficient. We have to work with the existing building stock because there are ways of turning it into a more efficient stock. Building operations are very important, and you can save a lot of energy with nice building operations. We have to think in systems being more efficient as a whole, buildings connected to the electric systems and interacting with them. We have materials that can be more efficient, less energy intensive. We have to think on resilience. Probably in the future, we might see some energy not being available for some times, and we have to make buildings that can resist to that. And of course, we have to think on clean energy for growth. Energy efficiency was something that was not on the International Energy Agency agenda, but in 2013, we've seen it becoming part of the agenda, and they defined it as energy efficiency as the first fuel to be used, because it will never finish. You can always be more efficient. When we think about weather, climate change, this study from IEA shows us that if we want to tackle climate change, avoid it, or minimize it, we have to think heavily on energy efficiency. Renewables are important, even nuke will be important, but energy efficiency is really the thing to be invested on. If you work on the area of cooling, and most of the people involved on this conference, people from ASHRAE, should read this book from IEA. It's The Future of Cooling. There are large opportunities for energy efficient cooling, and we are just skimming the surface, and we have to really dive in this to be providing more efficient cooling as a whole, not only machines, but systems, design, and everything. So read this book, that will inspire you. Speaking about the Brazilian energy system, I brought you some data here. What you can see is that as a whole, Brazil is consuming almost 500 gigawatt hours. We consume a lot on the industrial sector, but the residential comes just behind, and the commercial sector here also. So these are very important consumers of energy, and you have more data here. This presentation will be available for you afterwards to have a look on it. When we look into the consumers, we have 83 million consumers in Brazil. 72 million are on the residential sector, and then commercial is much less. But of course, the amount of energy used by the commercial is quite substantial also. But residential is really intense in Brazil. When we want to see how much energy is used in buildings, electric energy, we can say that 50% of the electric energy demanded in Brazil is for buildings. Half of this is for residential buildings, and the other half is for public and commercial building or non-residential buildings. When we look into our energy matrix, you can see here in blue on the left that 45% of our energy matrix is, the Brazilian energy matrix is renewable. So this is fantastic. When we compare ourselves to the rest of the world, they are only 14% renewable. So this is good. And if we look into the electric energy, we are even more renewable. When we think on the CO2 emissions per capita, Brazil is very small, only 2 tons of CO2 per inhabitant. And when we look into the USA, it's 15, China and European Union. So we have a clean energy matrix, and we have to keep it clean in the future. This is a bit outdated. It was updated only in 2014, but it's to show you the emission factor of our integrated energy system. And you can see that it is very low most of the time, and then it becomes higher when we have dry seasons, because we are heavily based on hydro. But here I can say that the electric system was handled in a very inefficient way. This was towards the re-election of Dilma, when we had an energy crisis due to some drought in the country, and the crisis was hidden to the population, and nobody was saving energy. So this was a pity. The other thing that is changing is the peak time. So if you see in blue here, you'll see the time of the peak during the cold months. So it's normally at the evening, after 6 o'clock in the evening, and it's generally associated to the electric shower. But if you look more to the right, you will see that in the hot months, the peak is moving to the afternoon, between 2 and 4 o'clock in the afternoon. And this is mainly air conditioning systems. So we have to be careful. Air conditioning ownership is growing, and mainly we're speaking here on the commercial sector that is working during the afternoon, and it's causing the stress on our electric system. So we have to think on that to be more efficient. Just a big overview of how strong is our electric system. We have a very nice interconnected system, as you can see on the right here. We cover most of Brazil. It's nice to see that our central generation system is heavily based on hydro. Wind energy is the second, but it's going to be doubled by 2027. We have natural gas, and we have solar that is increasing substantially, and it's bound to grow even higher on the next years. This is all governmental information, and I give you the reference here, but it's government. Distributed generation is also being invested heavily in Brazil, and here we can see the importance of zero energy buildings in the future and this kind of things. But you see that the forecast is to have 1.3 million micro and mini generation in 2027. So this is a sector that is growing substantially, and this is what we call green jobs. The strategic vision of energy efficiency in Brazil, we can say that the government, this is the governmental view, it reduces costs and increase competitiveness. It can higher the economic efficiency. It's good for business. It can delay investments in infrastructure, and it reduces social environmental impact. So it's good for everybody. Give you a brief history of energy efficiency in Brazil. The Brazilian labeling scheme started in 84. In 85, they started with Procel, the Brazilian Energy Efficiency Program. 91, they started Compet, that is the equivalent to Procel for gas. In 2000, we had the creation of ANEEL, the regulation body for the electric system. In 2001, due to the electricity crisis that we had at the end of the Fernando Henrique Cardoso government, due to lack of investments in the system and a dry year also, we had this law 10295 approved. It's a very important law that gives us the support to handle energy efficiency as part of the energy planning. And then in 2011, we had the first version of the National Plan for Energy Efficiency. It was a good intention, but not very well developed. In 2016, we had the approval of this law, 13280, and this gives money, a continuous flow of money to Procel. So this was a very interesting law to be approved also. Inside this law, this law creates this CGEE, that is the committee that takes care of the energy efficiency indicators. So minimum efficiency of appliances are approved in this committee. I am a member of this committee representing the universities. Inside this committee, we also have a group, a technical group working with energy efficiency in buildings, that I'm also a member there. So what's the governmental view of energy efficiency in buildings? They think that we need regulations, we need standards, we need training, we need to work towards compulsory labeling, and we need to put more energy efficiency criteria into residential programs from the government. Now let's start with what we are building. So first, let's start worldwide. So unfortunately, we are building buildings like this one in London. I don't know if you remember, but this one, it's a bit like a concentrated mirror, and it managed to melt the mirror of Jaguar that was parked underneath it. And it also sent a reporter from BBC to the hospital. So they had to put this dress on the building because it was a building that was giving a very high environmental impact to the vicinity. After that, they had to invest on this shading devices that you can see here. And you can imagine how expensive it is to put a shading device like this in a building after it has been built. But this means that we are not really making very efficient buildings, and when we do, sometimes we are sending the problem to the outside, to our neighbors. And we have many buildings like this in Brazil. And unfortunately, I didn't have some pictures to bring you examples, but this is only to give you an idea of what is being built in Sao Paulo, that you know. A lot of glass, and some of this glass can bring impacts to the neighborhood. So what we need really is labeling, certification, and perhaps seals. What's the idea of this? It's to evaluate building energy efficiency and display the information so the consumer can choose. This is the main reason for all these systems, and they are complementary. They complement each other, so we have to work with probably all of them. So what we have today in terms of building standards, labels, and certification? The construction industry is 10% of our GDP, and it's difficult to guess, but people say that almost 50% of the construction industry is informal and only 50 is formal. So it means that even with standards, we are not going to adjust the whole lot. A lot of informal buildings are being built all the time in Brazil. It will take some time until we become 100% formal. We have a minimum thermal performance standard for envelope of domestic buildings, residential buildings, that is the 15575. It's very, very basic, very minimum, and it has to be improved. We have no minimum thermal performance standard for envelope of non-domestic buildings, so it means that you can build a transparent glass box and call it a building, and then you will need tons of air conditioning to cool it down. So we need this kind of standards to avoid what we are seeing in some regions of Brazil. Building codes. Worldwide, everybody say that building codes are very important for energy efficiency purpose, but we see that municipalities cannot control our building codes. So building standards are much more important than local building codes. We have this high level of informality in the building industry, and we have to think on how to deal with it. We have energy performance certificates, this labeling system, voluntary. I'm going to speak about this in a minute. And it's only compulsory for federal buildings. We have some green buildings. In terms of new construction, Brazil has a bit more than 150 buildings that have been certified. But this, and we have also some energy performance certificates like the Procel label on 124 buildings that in terms of design, and part of them, 90 of those 120 became received the label for after they've been built. But I mean, this is very basic in terms of what is being built in Brazil. So let's speak a bit about the Brazilian program of labeling. It involves fridges, air conditioning, PVs, solar heaters, lighting, TVs, and buildings became part of this agenda. If you want to learn more about the Brazilian labeling scheme, you can watch this site, pbedifica.com.br, where you can find all information on labeling system for residential buildings and non-residential buildings. We started the system in 2009 with non-domestic buildings, and in 2010 with domestic buildings. And in 2014, it became compulsory for federal buildings. In 2014, also together with this compulsory need for federal buildings, we did this ordinance that asked all the everything that was bought by the government to be efficient. So the idea is, if the government buys a split system or car or everything that has a label, it should buy the more efficient one in the market. So how does the label work? We have a label given in two instances. One instance is the labeling of the design. So this is the intention to build. When you do the design, you have only an intention. And this label is normally confirmed or not confirmed when the building is delivered. So the idea here is to protect the consumer. So when he buys the intention or the design, he has somebody to check if the efficiency was delivered to him after the building was delivered. You can evaluate the building in two ways. One is a simplified way, like tables or simplified models. We used to call it prescriptive, but it's not so prescriptive because it has some modeling behind, like normally very basic models like regressions and things like that. But you can do the simulation, and the simulation is really the proper way of evaluating building. But with small buildings, normally it doesn't make sense to be involved in simulation. That can be a more expensive exercise. But with large buildings, I would say that we should be using more building simulation with these buildings because we can optimize them substantially. When we go for the residential buildings, we have three labels. One label is given to the individual unit, the other for the multifamily condominium, and the other for the common areas of the condominium. The method is trying to incentive a lot the building to work with natural ventilation. So what we evaluate here is really natural ventilation. During winter, we evaluate heating, and hot water is a very important end use on houses in Brazil. This is the label that we have today. It has some bonus that are given for some things like natural lighting, daylighting, rational use of water, and energy efficient cooling systems, fans to help to achieve thermal comfort and other things. And here at the top, we have the information if it is a label for design or if it is a label for a building that is already constructed. Just to give you an idea, when we take different climatic zones in Brazil, you have a different proportion of this end uses that are accounted to give the main label of the building. In residential buildings, we have 3,500 labels that have been given up to 2016. We need to update this information, but mainly you can see that a lot of labels have been given in Sao Paulo, and this was basically because one developer liked the idea of using the label and tested it for sales purpose and on people buying the apartment said, oh yes, I would even pay more to have an energy efficient apartment. That was very interesting for him. So this is one of the developments. All these apartments are A level. So it's not difficult. So you can see that it's an interesting idea to make it compulsory in the future, because when people are going to buy their flats, it's nice for them to have an idea of how efficient they are. These are other developments that received the label, and this here is the energy efficient house here in Florianopolis. That if you come to Florianopolis, you can visit it beside the Eletrosul building. So what about the new residential label? I mean, we've been working this in our last contract with Procel, but I should say that at the moment this is on hold because we need to integrate it with the changes that are going to be implemented in the Brazilian standard 15575. So we want to realign this with this. But you can see that now we are speaking about a new kind of label, more in line with the international tendency. So the evaluation here is on primary energy. So in this way, you can add electric energy with gas. That is quite common in residential buildings. Also, we want to show how the building works when it is naturally ventilated. We want to show emissions of the building, energy use. We want to show how much electricity is generated on site. So it's a label that is prepared to show net zero energy buildings. And we also put some information on the energy on the rational use of water. So the idea is to have this scanning thing, a QR code, that you can have more information and details on how this building was evaluated. Just moving to this revision of the 15575, this is happening at the moment, and we are improving substantially how it's going to be done. And basically, we are using the international tendency of comparing the real building with a reference building, as people involved in ASHRAE probably are aware of. We are doing an evaluation of the hours of use that you can have a reasonable comfort with natural ventilation, and this is the operative temperature range that we are accepting is 18 to 26. In some regions, when it's a hotter region, it goes up to 28, and in the hottest regions of Brazil, even 30 is considered quite acceptable by the population. So this is to give you an idea of how good is your house in terms of natural ventilation and bioclimatic design. We also check the maximum and minimum temperatures, and this evaluation is done during a whole year. And then we calculate the thermal load on the house during the whole year, heating and cooling load hourly for a whole year, and this can help you to calculate the energy consumption of the house. So this here will be the link with the energy labeling of Procel. When we get non-residential buildings, this is the label that we had. It was behind the scenes here. What you have is a very basic regression based on simulations, and it was mainly based on office buildings. But it's going to be improved substantially very soon. I will show you. So what we were evaluating here was the envelope of the building, the lighting systems, and the efficiency of the air conditioning. And the average of this will give us the efficiency of the building. With these old labels, it was impossible to calculate the energy consumption of the house. It was only giving the idea of how efficient it was. This is more distributed in Brazil, the labels that we had. This is the 100 labels that I mentioned before. Some buildings that received this labeling. Procel decided to do the seal. The seal is given to the most efficient appliances in the market, and for buildings, they decided to give this for buildings that were AAA. All the subsystems evaluations had to be A level. Also, we showed that the Procel seal was equivalent to LEED in terms of prerequisites of energy. So we reached an agreement with the USGBC, and this was accepted on the certification also. This was 2015. So this is the new asset rating for non-domestic buildings. This has passed a public consultancy 2 years ago, and now we are finishing the evaluation of the more than 600 comments that we received at that time. We are just starting a new agreement with Procel to work on that. And this should be published on the second semester. So the new evaluation for the new EPC for rating for non-domestic buildings is much more nicer than the previous one. It's also based on primary energy. It has these two phases, design phase and building delivered phase. It gives you an idea of how much energy you use for electricity and gas. It gives you an evaluation of the envelope of the building, how much energy you generate on site, what are the emissions of your energy use, and also rational use of water. So how does it work? Because I think this is more interesting for people with ASHRAE background. In terms of non-domestic buildings, we separated in end users. So we have the HVAC for cooling, HVAC for heating, and we have hot water. Some buildings will not have hot water, but some of the non-residential have hot water, like hospitals and hotels. So we estimate the annual cooling load. If this can be done via simplified method that is based on neural networks, estimation based on thousands of simulations. Or you can use, probably in the future, we are going to adopt ISO standards to do these calculations. And then you subtract the cooling from cogeneration, because this will be free cooling in a sense. And you divide by the COP of your system or SPLV, system part load value, depends what information you have on your system. And then you will have the energy consumption in terms of electric, if this is electric, or in cubic meters of gas, if this is a gas system for cooling. Heating system we considered not significant in Brazil, so we are not evaluating this. The loads are very small. And the water heating system is basically, you have the hot water demand, you multiply it by the energy used to heat. Then you take out the solar fraction or heat rejected, used coming from cogeneration, for example. And this will give you the consumption in terms of electricity or thermal energy. Or you can do this by simulation also, of course, just taking the easy part here of the simplified model. So your electricity consumption is subtracted by local renewable energy generated on site, and you multiply it by the primary energy conversion factor. The thermal energy also is multiplied by the primary energy conversion factor and added, and then you have the primary energy consumption in kilowatt hour per year or per month of your building, the real building and the reference building. And depending how much you saved from the reference building, you'll receive your energy efficiency class. So this evaluation is done in terms of primary energy. Speaking a bit about COP, SPLV, CSPF, so I mean, different ways of evaluating the efficiency of the cooling system. We started last year a transition from COP to CSPF based on ISO 16358. So to give you a summary, basically our split systems were only evaluated according to their COP. And now we are moving the evaluation standard to partial load also. So the seasonal COP is going to be evaluated in this way. So we are really trying to value more inverter systems that are much more efficient in partial load. So this is for small machines. When we go to large machines like chillers and cells and VRFs, they are not being tested at the moment in Brazil. So we are trusting manufacturer information, but we are working with Abrava at the moment to find a way to bring this market into a more trustable information. And probably in the future, we'll need testing labs for these big machines in Brazil. I don't know. Abrava is working to see what will be the best way to improve this information for consumers. So this part load operation efficiency are very important for the building labeling scheme. So we need to improve this here to help to calculate the energy used in the labeling scheme more efficiently. One of the standards that is very interesting for building simulations, as this conference is mainly on building simulation, is the ASHRAE 205 standard representation of performance simulation data for HVAC and other facility equipment. It's very important standard, but I have to say that, and all people that are listening here that are involved in building simulation know the difficulty that we have sometimes to obtain real and trustable information from the machines that we want to simulate. So we have to push this a bit forward and to have more better information on the performance of the equipment to be used on building simulation. Talking about the performance gap, I mean, we spoke about energy performance certificates that are given at the beginning of the operation of the building, but after the building is operated, sometimes part of this performance is not well used, or the possible performance is not really developed. You can say that, oh, and so we are selling illusions. Well, no. Sometimes the buildings are not very well operated. So you buy, you build a Ferrari and you put a truck driver to drive it. So he's not used to the performance of the Ferrari and does not know all the tricks that it has. So we have to improve this, and this in this area we are working with Brazilian Council for Sustainable Building, and together with Procel also, and we are developing the energy performance certificate for buildings in operation. What's this graph here? This is an information that was obtained during one of the projects that we had from CBCS with the help of people from São Paulo, consultancy firms, and these are LEED buildings. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 buildings. And you can see that this green here are using less energy than simulated. But all this use much more energy than was simulated during the certification of the building. Some much more. And we have some examples in UK that this value went up to 150%. So what's wrong with these buildings? The thing is that some of them have not been built as they've been designed. Some of them are not operated as well as they should. So what we need is really another checking method that will be a certification of energy performance in use. So this is done, it was started by CBCS, and at the moment we have a project together with Procel where 15 typologies of non-residential buildings are being evaluated, and we are developing this benchmark system for them. So this should be ready by next year. Talking about a bit the road ahead, if we look into the international scene, we are going to see ISO standards on the 52000 series, and these are standards that have been reserved for energy performance of buildings. So if you want to learn a bit more about this, go to this epb.center. You will see very interesting things happening there. And basically the recast of the Energy Performance of Building Directive in Europe is based on these ISO standards that are being developed, that have been developed very recently, 2017, some of them, and some are still under development. So what we plan here in Brazil is really to join this movement on the ISO 52000, and this should be the future for energy performance of building evaluation in Brazil in a few years. So concluding, building codes are very basic and not really followed. I mean, building codes in the sense that we have in Brazil, that are building codes from the municipalities. Standards, although they are not compulsory, they become compulsory due to the Consumer Code defense law. So if a builder does not take into account the standard and he gets prosecuted by the user of the building, he's going to lose the cause because a standard has to be followed. So in this sense, our standards are becoming compulsory. So we have this voluntary energy performance certificates. It's being improved with the time, getting in line with the international tendencies of evaluating primary energy. But we need building standards for energy efficiency. So this 52000 series of ISO are really in line of what we need. We need compulsory EPCs. So again, the ISO 52000 probably will help us. We need operational labeling because you cannot only trust the intention of the builder or the designer. We have to check when the building is operated, and a lot can be gained during this time. We need more professional involvement in energy efficiency in buildings. We need integrated design where most of the energy efficiency could be maximized. And we need more consumers pushing the market towards efficiency. So if the label becomes compulsory, the user will be able to check how efficient is the building that he's going to build. Investors can trust that they are really applying their money in more efficient building stock. So this is the future that we would like to see. I'd like to finish with this slide here. What we see here on the left is this is the footprint of countries done by these people here. And so here you have the footprint expressed in hectares. This dotted line here is the average capacity of the world as a whole. And here on the bottom we have the Human Development Index that will mean how educated is your population. So if you have a very highly educated population, you tend to be 1. So what we aimed would be the countries to be down here. So below the carrying capacity of the world and highly educated. You can see that we don't have many, only 1 here probably. This is the average of the world. So you can see that by the average of the world, it's already above the capacity, sustainable capacity of the world as a whole. These countries here are mainly Africa, subdeveloped countries. So the tendency that we see in this law, and if you go to the site, you normally can see the animation of it. The tendency is this. As you as you get more educated people, they tend to consume more energy. Some consume an absurd amount of energy, like Qatar here, for example. But we have to think on more sustainable development. And so if we want to push this line down here, what we need is really more efficient buildings, better operated buildings. Consumers can do a lot. I mean, building users have a big part on the energy use of the buildings. So we have to educate them. They have to be aware of the energy consumption behavior. And in this way, we'll have a better world altogether. So thank you very much for your time during this morning. And now we can open for questions. Do we have questions? Hello? So,
sorry, my microphone was deactivated. So
yeah.
There is a lot of questions here, Professor Lamberts. First of all, thank you very much for your presentation. It was very good. During your presentation, people was asking questions on the chat. Gabriel has completed it for us, and it's on the screen here. I will translate it to English. Juliana Pellegrini.
Shall we carry in English or? Yeah.
Up to you. Up to you. I will do the question in English, and you choose if you wanna answer in English or in Portuguese. We have on the screen English, in Portuguese, and I can translate to people in English, maybe.
Okay.
What do you prefer?
Oh, I can handle that. So Juliana is asking if what's the metric to be used for CO2 on the PB Edifica evaluation. So what we did is we have a document that was developed together with EPE, our planning body for energy in Brazil. And EPE has helped us to calculate the CO2 emissions of the integrated electric system. So it's the CO2 of the national integrated electric system. So to give you an idea, the transformation factor for electricity is about 1.6, and for gas is 1.1. But I can send you the document if you want. Just send me an email. Rafael Serra is a student of mechanical engineering, and he would like to know about the construction building materials on Energy Plus being adapted to the Brazilian reality. Well, in fact, we did a lot about this during our last project with Eletrobras on labeling, and we had an undergrad student that worked with Ana Paula, and he developed a library for Energy Plus based on the Brazilian components. So this is available on our website at LabE, but also if you cannot find, just send us an email and we can point it to you. Breno, the launching of the new system was meant to be in 2019 for the commercial buildings. The new date for it Well, what we agreed with Inmetro and Procel is to deliver this by August this year, and probably it depends very much on Inmetro to publish it, but we hope that it will be available by September or October this year. Eduardo Grala. Hi, Eduardo. He's asking about the heating load. I mean, I was speaking about commercial, well, non-residential buildings, and we the calculations that we did, even for zones 1 and 2, was irrelevant. But also, of course, this depends on the thermal comfort costumes. So what we see is that not many buildings have heating systems, and we thought that as the cooling needs were much higher than the heating needs, we tended to avoid them. But yes, it's an interesting discussion, and perhaps we can in the future put this together. You have more there? Yeah,
yes, there's more. Yeah.
He's asking about the part load evaluation system. They have to be measured. So we are now, Inmetro is finishing a public consultancy that they did for the CSPF for splits. And I think yesterday I received an email from them, and it's probably going to be finished in the next months. And the manufacturers will have to start measuring part load also. Some of the data can be calculated according to ISO, but some has to be measured. What we plan is in terms of the minimal efficiency and is to have big changes in 5 years. So this will have to be a bit slower than I would like to see. But we have to adapt, the labs to measure on part load. We have the manufacturers that have to adapt, moving to rotary compressors and to inverter systems and these things. And probably in 2025, we'll see a very high increase on CSPF for the A level on Inmetro label. But for big machines, we are still waiting for Abrava to speak with the manufacturers and try with and come with a plan on how to implement this in the market. Rafael was asking about existing buildings that want labeling. At the moment, I would say that the labeling is very, you see, the numbers were very small. So we don't have a big number of people being aware of the labeling system, and not many people really asking for labels. But the plan with the launching of the new system is really training more people and Procel really putting the label in the market in a more efficient way. Still, it will be voluntary, but there is a study that was going to be started very soon to evaluate the costs and the possibilities of changing this into a compulsory system. Of course, all this will take many years to happen, but we would like to see the government to send this, to put this into their agenda. Grala again, I think it's the same. But he's talking about, well, it's Grala again with the heating system about zones 1 and 2. And he says that considering the set points that 16401 adopts, there is a significant heating load for zone 1. Well, perhaps we can exchange some information on that. 16401 is under revision. It's a pity that it's taking a lot of time. It's probably 8 years now that it's being revised. But the new 16401 part 2 in the future will adopt ASHRAE 55, basically. And so it can be, we can accept a wider range than the 16401 accepts today, and probably more in line with how people operate buildings. But yeah, the heating is an issue for the cold parts of Brazil, and perhaps it will have to be implemented in the future. At the moment, we thought it was not worth dealing with it. So next.
Professor Lambert, there is more questions. They are not on the slide because they made it now. So if you can access on the menu there questions on the right, or let me try to write it here.
I cannot see anything on questions in my.
No? Okay, so let me.
You can read them, you don't need to write.
Okay, so there is Osvaldo Siqueira again is asking about the Brazilian market air conditioning, like mini splits that are about 75% of the equipments. What are the way to assure the installation of these equipments to match the electric consumption as the NBR 15.655, NBR 15,655 air conditionings. So this he asks, how to check if the installation is operating as in the right way.
Well, in fact, we have a lot of problems with installations in terms of the gas pipings, in terms of the electric connections. So yes, it's a big issue. It gets expensive. You can buy a machine for 1,000 reais, for example, and probably pay 500 or even more for an installation. So it's a substantial cost, and it can be very badly done. So perhaps we need a certification program for installers, and I mean the market has to be more efficient on that for sure.
There is also Alice Melo asking when they launching a new labeling method, will we need to relabel all the buildings again?
No, the labels are valid for a certain period, and if you see the Brazilian label so far, it's only an asset label. Asset label will mean a label to be used when the building is delivered to the client. So after it's being used, normally or old buildings, you're only going to do an asset label if you are going to be refurbishing the building, changing substantial parts of it. So the more efficient label for during operation is the operational label that is still not available, but will be available probably next year.
Okay. Yuri asks what kind of software he can use it to evaluate the energy consumption in a manufacturer, for example, or
in an industry.
Yeah.
Well, in industry, it's more complex than in buildings. In industry, the energy consumption is more related to process. So can say that then energy audits are more important, and you have to measure really the end users and see how effective they are being used. When you go to buildings, the energy simulation for buildings that we use is normally Energy Plus. It's a freely available software, but the interfaces to use are not really free. So if you want a nice interface like Design Builder, you will have to pay for it. If you want to use the free interface, the free engine, you have to go back to a bit more towards text input files. Some interfaces are available, like OpenStudio, but are limited. But in the future, we should see the integration of this building simulation software with BIM, and this is happening. We have a project in the lab at the moment where we see that it's starting to be possible to migrate from BIM geometric information data to building simulation.
There is 2 more questions here. One from Vladimir Souza. He says, thank you for the presentation. In the UK, architects have declared climate and biodiversity emergency. They have assigned a term reducing building emissions. Do you think that the action is likely to happen in Brazil, is useful to Brazil?
Well, we need everybody really be involved in climate change fight. But the emissions of the Brazilian buildings are small compared to the European buildings. I put the information at the beginning where the emissions per capita of a Brazilian is less than 5 times less than an European one. So when we think, and if you look into the international literature, you'll see that buildings are really the answer to climate change. I would say that in Brazil, not that much, because our electricity matrix is quite clean, still quite clean. But yes, we need much more compromise from the designers of buildings to make buildings that are more efficient. Sometimes we build buildings that the users have a hard time inside the building, and this should not be allowed. So in terms of standards, we have to help users not to see a building that is that bad, but we need designers really involved. And if we think on people involved in air conditioning design systems, I mean, there is a lot of things that are not only efficiency of the central machines like the chillers. The whole system can be designed in a more efficient way. This is something that we're trying to push together with Abrava in the new INI, the new labeling system for commercial buildings, and we hope to be more effective there. Yeah.
There is one more question from Gustavo Barea Mendonça from Argentina. He would like to know what kind of methodology to simulate change of weather on buildings. What kind of methodology?
Oh yeah, future weather. This is still an issue. We've been working on this. We did some work in the past. The PhD thesis of Andrea Triana in our lab used future weather for her simulations. I can point you out for that if you want. Send me an email. But we use the CC weather generator, CC World Weather Generator, or something like that from Southampton. But it still uses a previous version of IPCC for estimating future weather. We need a higher effort, and I think IBEPSA should be working on that in the future to provide future weather data nice estimates, of course, because we don't know how bad it's going to be. But it is possible to change weather files from today to see how they are going to behave in the future.
Okay. There is a last question here, Professor. Jerônimo Santos has asked, what is the principal reason why some buildings have a different energy consumption than the simulated, and how the standards Procel talk about the commissioning in the certification process?
That's a good question. Normally, when you are trying to certify the building, unfortunately, what we see in Brazil is very little involvement from the designer, the architect. He wants the building that he thought that he designed at the beginning to be tested and approved, mainly. He normally, during the design process, listens very little to advice on how the building could be more efficient. So in a sense, the certification processes are not very effective. If we had really integrated design where we had the architect working together with the simulating guy, with the mechanical engineer, with the services engineer, it would be we would have a much more efficient design. At the moment, we don't. And what happened is that sometimes people involved in certification probably push the line a bit too hard, and they believe that that the building will be used in a way that is probably not the way it's going to be used. So if you simulate with different loads, of course, the consumption will be different. And sometimes it is even difficult to guess. You build a building to be sold, and it was meant to be an office building, and it will become a conference call center with a completely different load. So there are many reasons for the real building consuming more or less energy than the simulated building. What we need is really a system that makes it compulsory to monitor the building. The new lead is asking this for the new certified buildings. They have to inform the energy consumption to check how well operating they are. But commissioning has a very important issue there, because commissioning is really checking. I don't know if everybody's aware of what commissioning is, but it's checking the design intentions and checking that they have been implemented in the real building. As I said, during construction, a lot of things happen, and perhaps some of the design intentions are lost. So commissioning has a big issue to help buildings being delivered more in line with what they have been designed.
Professor Lamberts, we are very glad to have you as our speaker. Thank you very much for your presentation, for spending this time with us. I think the presentation was really with a lot of content that can enlarge the knowledge of our area. Thank you very much.
Thank you. It was a pleasure for me also.
So I just would like to give some reminder for our audience. We're gonna have a second webinar this afternoon at 2 p.m. Brazilian time with Ros Montegori. If you have a question it was not answered, you can send an email to us, and we can forward it to Professor Roberto Lamberts. Forward to the email in the bottom of this page here. So I hope you see to see you guys again this afternoon with House Montgomery. Thank you very much for everybody to attend this this webinar. And if at the end of this conference you're gonna receive a certificate of attendance, if you'd like a different kind of certificate, such as for PDHs that some people like, send an email for us too, that we can provide. Thank you very much and see you on the afternoon.